It has no office, no staff, no director. Yet it has flourished for 50 years. Cooperative Research Ships, CRS. The secret to its success is committed people working together. More than 20 shipyards, ship owners, navies, equipment suppliers, classification societies, and research organizations perform research on vital topics for an annual budget of around 1.5 million euros. CRS is a simple organization for complex research, dedicated to making ships cleaner, smarter, and safer. See for yourself as we share some of the research highlights. The impact of green water can damage a ship, its cargo, and crew. In green water, model tests generate validation data for the screening of green water events and calculating pressures and forces on the superstructure. Pressures are measured at 90 positions on the breakwater and the side of a container stack. We studied slamming forces against the bow. This ferry is sailing at high speed in bow-quartering waves and is experiencing high wave loads. The loads are measured on 10 separate segments in the forward part of the hull. The results give a detailed view on the magnitude and distribution of the impulsive forces and are a unique source for validation studies. Dynamic stability is about the stability of a ship in waves. This is the research topic of the Dynasty Working Group, which aims at numerical and experimental methods for assessment of failure modes. Parametric roll is a phenomenon that can occur in ships sailing in near-head seas. Large vessels can suffer from roll motion, rapidly building up to amplitudes of 20 to 30 degrees. Predictions stemming from simulations have become more relevant than ever, now that parametric roll has been included in the new IMO stability criteria. The Dynasty Working Group compares different prediction tools with model test results. Another failure mode in the new IMO criteria is loss of stability. Ships with low stability are vulnerable in stern quartering seas, where the encounter frequency is low. The consequences can be dramatic. Here too, the Dynasty Working Group compares different simulations with experimental results to make sure the CRS community is ready for the new rules. The propulsor of a ship can be analyzed by a suite of tools developed by CRS. The flow around the propeller operating in the ship wake is computed using a boundary element method. The panel distribution for this propeller can be generated by a graphical user interface, which is also used to visualize the results. With this tool set, the designer can predict shaft forces and moments as well as sheet cavitation dynamics for open propellers, podded propellers, and propeller duct combinations. These results can be used to predict the propeller-induced pressure fluctuations on the hull, which lead to onboard vibrations and noise. Semi-empirical models have also been developed to predict the underwater radiated noise by a cavitating propeller. The Sharks Working Group focuses on verification and validation of predicting propeller cavitation-induced noise and vibrations. RAN's sliding interface computations, including cavitation for a propeller behind a combi freighter, showed that the cavitating tip vortex formation compared well with high-speed camera observations. Lower fuel consumption means lower speeds at sea, which often means smaller engines. But can a ship with a smaller engine still operate safely in adverse weather? Propellers are optimized for operation in calm water. There is little knowledge about their performance in waves or during maneuvers. This is the focus of the PELS working group. Oscillation experiments are performed with propellers that operate close to the water surface. The oscillation frequency is increased gradually to provide as much information as possible from a single experiment. The forces and moments that act on the propeller are measured. Oscillations are performed in axial, transverse, and vertical directions. Air is drawn from the water surface. These experiments help determine the effects of ventilation on propeller performance and can be used in the safety assessments of ships sailing in bad weather. Evaluating wave-induced structural response is fundamental in the design verification of a ship's structural integrity. CRS is performing state-of-the-art research in this field. Here, we see the stresses in a container vessel that were obtained from time-domain hydrostructural simulations. Over the past 5 years, the RAW working groups have investigated the added resistance in waves and the benefits of alternative prediction methods. The added resistance of some ship types is well understood and can be predicted by both linear theory and CFD. For other ships, however, the added resistance tends to exhibit nonlinear characteristics, making it difficult to predict operational performance. The growing use of podded propellers due to increasing shipping in ice-covered waters means that we need to know more about pods in Arctic conditions. The shipping industry specifically requires facts about operational limits. Empirical data is sparse, and information about ice loads on pods is becoming more crucial as the size and power of the pods increase. In the MORE projects, we look at new operational requirements at low, medium, and high speed. These requirements include unconventional calm water maneuvers, such as turn on the spot and acceleration turns, and maneuvers in waves, such as course and track keeping in different sea states and speeds. CRS MORE aims to develop knowledge, tools, and know-how to verify these new requirements and maneuvers. Within a rapidly changing world, where new techniques emerge and become mature faster than ever before, CRS is taking the challenge to maintain its relevance for the maritime world. CRS has demonstrated its ability to grow and change. New trends and developments provide fresh opportunities for research and will define the main themes for CRS in the decades ahead. Whatever the future may bring, CRS is committed to provide knowledge, a specialists network, and practical tools for its members. After 50 years of commitment, relevance, and sharing, CRS is ready for the future.